Welcome to your quick math lesson on the second index law, negative and zero indices. So we're going to get straight into it with the following problem. And the question is, write the following expression in its simplest index form. So we have 2 to the 5 over 16. Well, straight away, if you notice, we have a number here in its index form. See here, we have our base, which is 2, and we have our index, which is 5. And so we want to put 16 in index form as well, so we can see what we can do with this fraction. We might be able to cancel out any like terms. And so the best way to do that is that we're going to break up 16 into its prime factors. So we know that 16 is equivalent to 2 times 8. And we know that 8 is equivalent to 2 times 4, and that 4 is equivalent to 2 times 2. So what we have is 2 times 2 times 2 times 2, which is 2 to the 4. And so our new expression, it would look like this. So now our expression is in a form where we can use our second index law. So remember our second index law is a to the m over a to the n equals a to the m minus n. So we have here 2 to the 5 over 2 to the 4. Notice here that we can use our second index law because the second index law only works if both of our bases are the same. In this case, they're both a. And in this case, they're both 2. So we can use our second index law. And so what we would have here is that we would have 2 to the 5 minus 4 equals 2 to the 1. And that was pretty straightforward. So let's move on to our second question. Alright, so we have our second question here. Hopefully this question is a bit more challenging. So notice straight away we have 5 cubed multiplied by 2 cubed divided by or over 5 squared multiplied by 8. And so again, we want to break down 8 into its prime factors, and hopefully its prime factors would evaluate to either 5 or 2 to help us with our cancellations. Remember, we want to get 8 into the form a over m, right? That would be our index form, where a would be our base and m would be our index. So we know that 8 is equivalent to 2 times 4, and that 4 is 2 times 2. So 8 is 2 times 2 times 2, which is 2 to the cubed. So we can rewrite our expression as 5 cubed multiplied by 2 cubed over 5 cubed multiplied by 2 cubed. And look at that, we just got lucky. We have 2 over 3, 2 to the power 3 over 2 to the power 3. So both of these terms here, they can just cancel out because they are the same. So it's equivalent to 2 over 3 is equivalent to 8, obviously. So we have 2 over 3 over 2 to the 3 over 2 to the 3, which is 8 over 8, which is equivalent to 1. So the whole thing just cancels out, and so what we're left with is 5 to the 3 over 5 to the 2. And then of course we could use our second index law. So we have 5 to the 3 minus 2 equals 5 to the 1. And we'll leave a 1 there to show that we have indeed simplified our expression into its simplest index form. Alright, so that was a bit more challenging. So our next question, we're going to introduce the concept of a zero power. Alright, so we have our next problem here as 5 cubed minus 7 squared over 3 to the 0. And so we immediately run into a problem, because how do we evaluate 3 to the power of 0? So just bear in mind that 0 equals 1 minus 1. It also equals 2 minus 2. Also equals 3 minus 3. And so you get the point, right? And remember our second index law states that a to the m over a to the n equals a to the m minus n. And so in this case, we could actually make m equal to n. So we're going to make both of our powers have the same value to come up with 0, right? So if m equaled 3 and n equaled 3, then m minus n would equal 0. So in the case of 3 to the power of 0, we know that we can say 1 minus 1 equals 0, right? So how do we get 1 minus 1? Well, using our second law of index, we know, or our second index law, we know that 3 to the power of 1 divided by 3 to the power of 1 equals 3 to the power of 1 minus 1, which equals 3 to the power of 0. And we also know that 3 to the power of 1 over 3 to the power of 1, 3 to the power of 1 over 3 to the power of 1 is equal to 3 over 3. It's the same thing, right? And we know that 3 over 3 is equal to 1. And so 3 to the 0 equals 1. And in general, any number a raised to the power of 0 always equals 1. And we can test that, right? Let's say we had 7 to the power of 1 over 7 to the power of 1. That would equal 7 to the power of 1 minus 1, which equals 7 to the power of 0. And we know that 7 over 7 also equals 1. And so there we have it. Alright, so we're starting to warm up a bit. Let's take a look at our next example. So we have here 2 to the power of 2 over 32. Alright, so how do we deal with this one? Well, straight away we know that we have 32, we want to put 32 in its simplest index form. And so we're going to go about doing that by using our prime factorization method. So we know that 2 times 16 is 32, and that 2 times 8 is 16, and that 2 times 4 is 8, and 2 times 2 is 4, right? So 32 is 2 times 2 times 2 times 2 times 2, which is, of course, 2 to the 5. So what we have is 2 to the 2 over 2 to the 5, and then using our second index law, we have 2 to the 2 minus 5, which is 2 to the minus 3. And so immediately we run into a problem because we have 2 to the power of minus 3. And so how would we evaluate 2 to the power of minus 3, especially if our question asked us to evaluate the expression and to put it in its simplest positive index form? We would want to make this term give it a positive index form. So how would we do that? Well, we can rewrite our expression as 2 times 2, because we have 2 to the 2, over, and we have 2 to the 5, right? So we have 2 times 2 times 2 times 2 times 2. So we've rewritten our expression in its factor form. And so now what we can do now is we can just cancel out our 2's above here. And so we're left with, well, we know that that's just multiplied by 1. And so we're left with 1 over 2 times 2 times 2, which is 2 to the 3. And so we notice here that 2 to the power of minus 3 equals 1 over 2 to the 3. And in general, a to the power of minus m equals 1 over a to the m. Alright, I hope this has given you a clear understanding of our second index law. Don't forget to like and subscribe, and I'll see you again soon.